So today, while I was out running around, I picked up this Transmation Incorporated Model 1045 precision voltage current reference. It can be used for all kinds of things. The manual is interesting. But one of the things it can do is be a precision current or voltage source. It does power on. Let's see. Right now it's set to millivolt output, and I'm going to bring the output as low as it'll go. So I've got the coarse and fine adjusted. It should be all the way to the left. That knob's loose and just spinning on the shaft. It's got enough grip to actually turn the shaft. Anyhow, I've got behind us here my Rigol 3058E, which is by far the most precise instrument I've got in the lab. And I thought I'd basically give this guy a whirl on here and just see what we've got. So I show minus 10.87, actually minus 10.88 millivolts output on the 1054 or the 1045, and I'm sure you can see that as well. I'm going to try to bring this up to exactly 0. If I can get it there. Take some futzing around here. Even with the coarse and fine adjust, it's minus 2, minus 8, 6, 5. 0.07, 654. So I show 0.00 millivolts output on the voltage reference here, and as you can see, that's pretty consistent with what we have on this, on the DMM here. That actually makes me really happy. So let's bring the current up to 1 millivolt. Wow, it is so twitchy. And we'll kind of walk through some of the ranges here and see what we get. So there's 0.96789, just over. This is showing 1 millivolt, and that's showing 1 millivolt, a tad bit above, but well within the spec for this thing. So, no, I'm a little under a millivolt. The screen is flashing. I'm impressed for however old this transmission instrument is. That's actually surprisingly spot on. Let's go up to 10 millivolts. Get spot on 10 millivolts. Spot on 10. Now I'm a little high still. Okay, the screen settled down on the unit, and that's a little under now. We're spot on here. Let me try, 10.02 if I can get. There's 10.02. It's a little high. 10.05 if I can get it stable on 10.05. A little under. That's pretty close. Amazingly, for as old as this is, it seems to be actually in pretty good calibration. Let's bring it up to 50 millivolts. I don't have a precision voltage reference for my bench. Although, honestly, I don't know that I've ever really had a need for one. Let's see if I can get this up to 50 millivolts. But based on what I'm seeing here, comparing it against the Rigol instrument, so there's 50.00, and that's off by about a millivolt, a 0.01 millivolts, so at 10 microvolts. Again, amazingly spot on. Let's double it up again to 100 millivolts. I don't remember exactly how high this can go. Actually, it's not going to go above 99 point over range. So full scale on here is 99.99. 9.5, 9.6, 9.7, 9.8. So there's just a tad bit high. So there's 99.99 millivolts. That's actually pretty precise. I'm actually impressed that this old piece of gear is that precise. I know, looking online, knew these things were thousands of dollars. I looked at the last 4 sold on eBay, and they sold from $2 to about 80. Let's kick it up to the 10 volt range and see what we get. Suddenly not looking so good. That should be 9.6 volts. And we're obviously not seeing 9.6 volts. We may have found how this failed. Oh, there it is. I just need a better connection. So I'm at 9.624 volts on the unit, 9.6245. Wow. Let's see if I can get a very precise 5 volt reference. So 4.97, 4.98. Again, I'm reading this off of the screen on the transmission unit. 97.998, 999. And the transmission unit shows 5.001 volts. Spot on. That's actually pretty impressive. Looks like I may have a very nice little precision voltage reference here. The other thing this thing can do is drive current. I'm going to bring the voltages all the way down and switch it to current mode. And it's a milliamp drive, and we'll take the meter here to current DC. And I'll bring it up to, if I can get it to go up, to I should be able to drive current through the shunt resistor in the meter. Oh, I know what I've done wrong. I am connected to the wrong terminals. Let me back this all the way back down. And the correct set of terminals for driving current are these two. Now let's bring the current up. Well, so far no love. Milliamps, millivolts. I would expect that to be driving current through the current shunt in the meter. Current DC. Well, we may have found out why this thing was surplus. Let's drop into a fixed resistor here. Have a play at it. Of course, I don't have the proper test leads for this. Which of course makes this a challenge. Find a couple of leads that'll do the job here. Sorry, I'm digging for leads. So we'll go to the resistance side here. Resistance low. Take this to 100 ohms, which I know isn't real accurate. And we'll just so it is driving current into the resistor here. So what I need to do is get this in a loop. So we'll take the negative from here to here. I don't believe I can get that jack in there, can I? I guess I can. And we'll take this lead out. Of course, that's not going to work for me. So I've got the meter in series with the resistor, and what am I doing wrong here? That should be... Oh! Have you spotted what I'm doing wrong? I know what I'm doing wrong. I'm trying to drive current into the volt jacks. I'm being dumb over here. Certainly not the first time today. So if I remember right, we drive current on the jack down below. That gets us into the current shunt. And now, without the resistor decade box, we should be able to measure current. So I'm showing I'm driving 24.21 milliamps on the unit here. I'll hold it up here so you can see 24.21 milliamps. Hopefully you can see that on camera. And it matches very precisely with what's on the meter here. Let's bring this down to... So when I take it all the way down, it's negative 0.49 milliamps, which is pretty close to what we're seeing there. Let me bring it up to 50 microamps if I can get it there. 50 microamps. So we're pretty close. I don't know what kind of current this is good for. We'll get up to 5 milliamps. And 5 milliamps. So this guy's actually working pretty well. That's pretty impressive just for a constant current, constant voltage source. Uses a reference or whatever. That's pretty impressive. Let's see if I can get up to 10 milliamps. And there's 10.02. Need to tighten this knob up over here. 10 milliamps, 10.01 milliamps actually being displayed here, and it's kind of jumping between the 10 and the 0.00 and the 0.01. So, what kind of current are you capable of driving? I'm assuming you'll go all the way up to... No, it seems to have topped out at 27 milliamps. So it may only be good up to like 25 milliamps. I'd have to look in the manual. Again, this is driving that current shunt in the meter over here, which is going to be a very low resistance. Anyhow, that's rather interesting. I guess the flip side of this, so 20.30 milliamps, 20.293 milliamps, it's pretty damn close. Not that I would be using, well, this is for driving current, and I'm measuring the current. Don't know that I'd be using the input side of this to measure millivolts, volts, etc. when I've got a unit here that is much closer in calibration to now, and honestly has a lot more accuracy. But you know, for $11, including sales tax, I picked it up at my local Goodwill. Came with a little power brick. Gives me an interesting little, you know, precision voltage, precision current source. Let's see if we go back to measuring volts here. Trying to think of a mode on here like diode check will drive current. So if we put this on input, and we're going to measure milliamps, millivolts, 10 volts, millivolts. Where would it be measuring 10 volts at? I'm guessing here and here. We should be able to see the current it's driving to oh, and once again I'm being a fool. I need to get back to here. I'm not sure which set of leads I should be using here, or which set of plugs. Again, that's just basically telling me there's a go back to the millivolt range. So it's driving an over range, no surprise. Anyhow, this will be a short video, but there is the Transmation Model 1045, precision voltage, current source, and with precision measurement capabilities. It's in actually an aluminum case. Based on the photo, I thought it was just a cheap plastic case, which didn't make a lot of sense given the you know, street retail price of it so long ago. I know it's got a pair of a set of NiCad 4AA NiCad batteries in the base down here that are charged. It does seem to hold a charge for a bit. I haven't tried to fully charge it. Just so you kind of see the whole thing. There's of course the power switch, and it's a pull to release and lock. Coarse and fine adjust for the voltage or current reference, whether this display is reading input or what it's trying to drive out. And of course a couple of range switches, milliamps, millivolts, 10 volt, 50 volt, and of course driving milliamps or millivolts, or driving tens of volts. So interesting bit of kit, doesn't take up a lot of room. It's probably something I'll go ahead and keep, say for $11 including sales tax, and there was no shipping because I did local pickup. You know, I think I scored. Of course, if in 5 years I've not used it for anything, I guess so be it. Anyhow, I'll wrap this video up here, and we'll talk soon. Bye. So we just took a quick look at the this Model 1045 constant current, constant voltage source here that's got, you know, high resolution measurement capabilities and stuff. And of course, I forgot I was going to open it up and take a look inside, and didn't. So let's go ahead and do that. Hopefully I've got the right size Allen wrenches here. I'm sure it's full of 1970s goodness. Through-hole construction, I would guess. But we'll find out when we get inside. So. I said a minute ago, I just thought it was in a cheap plastic case, which was kind of like, you know, what the heck, seeing what the retail pricing on this was when it was a new, you know, item from back in the day. So, you know, finding this nice aluminum case is actually rather nice. So we'll see what kind of goodness we find inside. I'm actually pleased that it works. Something like this, I don't really have the ability to calibrate to any high standard. You know, I've got my Rigol meter, which agreed surprisingly well with this. Not dissing on Rigol, I love their equipment. Just the fact that this just, you know, from so long ago seems to be well calibrated overall. I'm sure in some way with those screws out this slides apart. There we go. The bottom of the case will slide off. Let me see if I can get this end cap off. It's got a rubber seal to it. We can see a nice LCD display in there. Nice through-hole construction. To decide which way this slides to come apart. It seems to be neither way. We know that it has to slide apart. So it's this jack here, currently keeping it from coming apart. It just looks like it's press fit in there. And we'll give it a little bit of persuasion here and see if it'll pop out. Doesn't seem to. Is it screwed in there maybe? It's got flats on it like it might be threaded. Yeah, it's threaded. There we go. Slides the bottom off the case. As you can see, there's an intercell, ICL7135. Date code looks to be the first week of '89. There's, of course, this little NiCad battery pack, which directly soldered in. Don't know what kind of actual condition it is in. It's all through hole. Make sure I've got this in camera. As I said, there's the intercell, ICL7135 CPI sitting up here. Let's see what else might be of note. There's another intercell chip here, I believe. Or not, it's TSC. I'm going to have to get the other pair of glasses. If you're used to my videos, you're used to me swapping glasses. So this is a TSC 7650. Just a 4040, some CMOS logic, a 4013 CMOS logic, a 4047 more CMOS logic, another 4049 CMOS logic. I would expect someplace in here to find perhaps a precision voltage reference. That might be, no, that's an LM358. So that's just an op amp. I'm not sure what this little shield here is for. It is metal. There's some inductors underneath it. I don't know that I'm going to attempt to tear this down any further. I don't think there's a whole lot left to see. Calibration pots, the internal switches, and the potentiometers, etc. They are, look like be probably Bourne 10-turn potentiometers. Again, all through hole. In order to get the board out, I need to remove all the nuts and the knobs and everything off the front, and I'm not feeling enough need to do that. You know, they are just flat ribbon cables that jump. I assume this is probably going to the LCD. Yeah, it does. You can see the LCD up here in the red socket. I see 1, 2, 3, 4, 5 trim pots down here, which have been set and cemented. There's another one up here for 6. And there's one here on the side. I know the manual made mention of the trim pots. We have a little transformer or coil or something of some kind here. It's got a number of leads in and out of it. Some kind of an inductor. You know, it's very typical construction for the 70s, 80s. The PCB layout looks like it was probably hand taped. I mean, can't guarantee that, but given the age, it was most likely hand taped. I don't know when this was first manufactured or how long this lived. I see what this metal plate is for. There's a 3-pin device up under here. It's most likely a voltage regulator, and that's playing heatsink for that voltage regulator. So that makes more sense. There's a 0.75 ohm resistor here, R25, that's probably a current shunt, given the size. 250 microfarad, 5 volt DC, 105 degree, or 25 volt DC, 105 degree cap sitting there. I'm guessing that's probably got to do with power management. Lots of precision resistors. You know, just pretty typical construction for the era. Don't really know what else I can show you here. You know, these jacks on the front are of course soldered directly to this inner board. It's actually a pretty thick board. I think it's actually a little thicker than, well, maybe not. It just seems thick looking at it. Definitely fiberglass. Not a whole lot else to see. So, you know, as many measurement devices were back then, you know, based on the intercell chipset. I'm sure that's probably, it's got to be, you know, it's the driver for the display. You know, the majority of the functionality sitting right there. I'm really kind of surprised I'm not finding anything that I recognize as a precision voltage reference. I don't know what this TSC 7650 is. I guess I could look it up. Maybe it is, maybe it isn't. I don't see any kind of strain relief cut into the board where there would be a voltage reference, you know, to isolate the device from board flexing and you know, thermal expansion, contraction, those kind of things. And just a handful of Jelly Bean CMOS logic. Well, anyhow, there's the view inside. We'll talk soon.